Good morning, everyone. I'm Saai, Krishnan, Udayakumar, and with me we have Dilip, Mandadi. Today we'll be talking on the topic securing access, leveraging IGA, JIT, and policy controls. Okay, so the inspiration, we saw that we have the OWASP top 10, which is broken. There's a bunch of items, but we wanted to tackle the very first amongst them, which is broken access control, and also the OWASP top 10 for non-human identities. And that, again, the top one is improper offboarding of identities. So with that, brief intro about myself. I'm a software engineer at Salesforce, and I've been in this IGA and IAM space for the last 10 years. And my primary goal is to make sure that we can build secure services and applications leveraging all these tools that we have in hand.
Okay. I'm a senior product manager at Salesforce. I primarily... Oh. That's okay. I'm a senior PM at Salesforce. Currently, I am working on an AML platform. In the past, I've also shipped customer identity and access management and enterprise identity and access management governance solutions to Fortune 500 companies.
Okay. So for this session, we said, okay, what would be a nice stat to go with, right? A report from Sophos said that about 77% of attacks that happened in 2024 alone were used because of compromised credentials as the initial method of access. And the staggering fact is that 63% of the organizations, they acknowledge this as one of the highly sensitive access in this organizations is not properly secure. And OWASP itself in its readings state that about 94% of applications were tested for some form of broken access control. So with that, we segue into our agenda on what we are looking to cover. A brief roadmap. So about we've split our talk into 6 different parts. One, focusing around what the broken access control is all about. And then we want to talk about the improper offboarding of non-human identities and move on to the modern solutions that we have at hand, like IGA, JIT access, and policy controls. And then we will be touching about a hypothetical application, what we call as the cloud finance application, and see how we can leverage all of these various modern solutions that we have at hand. And then we look at how it helps reduce the risk score. And then we move on to talk in detail about this AI-enhanced access management. And finally, we'll be wrapping up with some of the implementation strategies that we feel like might work for different organizations. So let's dive into the first part, the understanding access management, right? So this image is just an illustration of how complex systems are, right? And modern enterprises, you have about anywhere between tens of thousands of users all the way to an equal number or way more number of applications that are present. And if any person joins a company, you'd easily notice that they need at least access to 15 different systems that are there in place. And to add to that, we have different personas. We have users, we have, say, contractors, partners, or even non-human things like service accounts, APIs. And all of these things add to the mix. So we can clearly see there's a pattern of vulnerability that can easily evolve in this environment setup, right? And especially our focus being improper offboarding of human accounts and broken access control, this would give an illustration of where we are looking at. So in OWASP top 10, the A01 2021, I think since 2021, we've been having broken access control as the top threat. And when we say broken access control, OWASP has identified 34 common weakness enumeration types, 34 CWEs, and all of them are mapped to A01 2021. And in essence, what does it mean when we say broken access control, right? It occurs typically when applications fail to restrict access especially for authenticated users, and decide like what they could do. Like, can you just view your data, or are you accessing another user's account, or are you viewing sensitive files, or modifying permissions, elevating any additional privileges? So these are like various forms which reflect that these are all broken access control. And one of the key statistics that we have, like I said, 94% of the applications were tested for some form of broken access control. So when access control fails, so we picked up like 3 case studies from real world, right? And we've abstracted the names of the companies. But in the first case, we had like a major healthcare provider who had a vulnerability where simply changing the patient ID number in the URL allowed access to their patient's medical record. So that would basically mean you're violating some of the HIPAA compliance and many other related things, right? And in the second example, we had like a financial company which had an API endpoint that basically verified authentication, but failed to authorize for specific resources, which means they allowed authenticated users could access any customer's financial data. So, and finally, we had another case study of an e-commerce giant like suffered from like parameter tampering vulnerabilities. When I say parameter tampering, it's basically like you could modify the account IDs and go and edit somebody else's cart. And like basically, in all of these 3, you will notice that there is a pattern where all of them were able to authenticate, but there wasn't any restriction around like what they could properly do after the fact of authentication. So why does access control actually break, right? So when we say there is a persistent challenge in this space. Now, in many organizations, access control is implemented in a decentralized manner. And because of the complexity of how these various applications and stuff exist, and as a result, like say you have even legacy systems. And when we say legacy systems, they don't have any standard protocols for integration. And we also have overprivileged accounts. When we say overprivileged, because there's always this mindset that you need all the access for you to get your job done, much more than what is actually needed. So in the name of productivity, there is a compromise towards security. And fourth, we have many systems which lack the granularity that is needed. Typically, I've noticed applications where you just have 2 roles, like an administrator and a user. But say you just want to update a certain section of an application, you don't need to be an administrator for doing that. You just need a granular permission to achieve that. And finally, like you also have like some lack of continuous verification. When I say verification, there's also, most applications are in the world where you get a certain role, they just authenticate, authorize you with that, and then done. But there isn't a periodic verification whether if you're still having are you still in possession of that said permission or role. So these are different access control breakage points that we experience. So this is like a fun meme that I present to my team in general. Like, basically, we know the fact that the problems exist. And all of us acknowledge that there are problems like this that exist. But somehow we become immune to it, that we say that this is fine. This is fine up until something actually breaks. So this just want to capture that. So for the second part.
Come in. Thank you. So since we had a few people joining now, I just want to recap what we are talking about in this session today. We're talking about identity governance and how we can have different strategies in place to secure different identities in a large enterprise organization. Again, I want to kind of recap. Authentication, authorization, and identity governance are different problems. Authentication deals with proving who you are. Authorization deals with making sure you have the access for what you're trying to gain access. For example, if you're entering a bar, a person outside of the door checks if you're who you claim to be. That's authentication. And authorization is the fact that you are more than 18 years of age and you are eligible to enter the path. That's authorization. And identity governance deals with process of issuing you the identity. And it comes into picture both for human identities and non-human identities. Today, we have a higher degree of focus on non-human identities in this session. But we do take a broad approach here. So let's take a look at it. So non-human identities are one of the OWASP top critical risks. They go beyond human identities, and typically they involve accounts like service accounts, API keys, and machine identities in your enterprises. NIH 2025 is one of the guides you would want to look at to understand more in detail about what these non-human identities are, what are the risks involved for your respective enterprise companies. They did make it to top of the list there. So let's go on. The reason non-human identities are important from a risk perspective are they are typically not managed just like a typical human identities provision. For example, when you would have joined a company, you would have been provisioned your identity through an automated system, right? You wouldn't even know how your mail was provisioned. You would have received an email and you would be accessing it one day. But a non-human identity doesn't happen, provisioning doesn't happen that way. Typically, an enterprise administrator who is shipping an application is working with multiple systems to provision non-human identities. And in a lot of companies, even the mature ones, even in Fortune 500 companies, they're not tracked well. You wouldn't have a single registry in the company where you can go and see what are all the non-human identities that exist in my company. It would be really hard to find that answer, even in the biggest companies in the US or anywhere in the world. It has been a hard problem to deal with, primarily because it's a process problem, I believe, more than a tech problem. What happens with non-human identities? Typically, you would provision a service account for some project, give it a bunch of permissions. 1 year down the lane, your project is shelved for whatever reason, but the non-human identity would still linger over there. That's what we call an orphaned non-human identity. The problem with non-human identity specifically is that because they linger, any malicious actors who have been able to gain access into our environment will be able to use those non-human identities and gain privileged access. Typically, they tend to have administrative access. So, which is why it's important to keep a tab on them. We briefly covered this right before. Like I said, they typically tend to have extensive privileges, typically administrative in nature. They are also long-lived credentials, and they tend to go beyond typical human oversight. So, and the auditability is a little less than human identity because they're not integrated with your Okta's or Microsoft Entra's or whatever. They have their own authentication systems, which tends to go a little outside of a regular human site. I think we brought this up. When you try to figure out who created a service account with admin privileges, it tends to be a blame game. We see this quite often in companies. Let me give it. I think what we wanted to cover in this previous session, in the previous segment, was to help you understand what non-human identities are and what are the challenges that come with them. Now, Saai will talk about how different solutions can be used to mitigate some of the risks involved in non-human and human identities as well. Thank you.
Thank you. So, thanks, Dilip. So I think moving on, so when we look at all these different solutions that are in place, right, one of the key aspects is moving beyond just static access control. So now, when we break it down, like the access management process itself has also evolved over time. At one point, there used to be like static role-based access. And now we're looking towards a world of policy-driven, dynamic policy-based access. And we're also shifting from typical manual provisioning processes to more automated and sophisticated lifecycle management. And there's also the periodic reviews that happen, which are now moving towards a more continuous monitoring and verification based approach. Now, this also kind of shows a fundamental shift in how we think about what an IGA system could potentially do versus what it was used in the past, which is mere as an auditing tool. So as we step in, right, like I just mentioned, at one point, IGA systems were just looked as a tool for auditors to verify whether the user has a said access and merely for compliance purposes. But now, it's a more complex product that is out there for us to cater to various scenarios that, some of the capabilities that are listed there. Say whether it is a standardized access request or a standardized approval process or some form of automation towards the provisioning and deprovisioning those accesses. We also have like some form of standard access certification. And the enforcement of these things like say role and policy management, as well as like segregation or separation of the duties that are performed by each of these layers. So when you actually use these standard approaches, it helps reduce the security and the operational friction that come along with it, which otherwise you would have dealt with 15 ticketing tools for getting somebody a necessary access that they need. Instead, now you have an automation which can control and drive the whole concept end to end. So want to segue into just-in-time access. Now, this is also a paradigm shift, and especially in my own company where we are trying to move people to more just-in-time access approach, where there's always this feeling that people need all access all the time. And that comes with the thought that, what if I don't get the access when needed, right? But instead, the focus should be around, do you need so much access all the time, or can you be good enough with what you receive at the given point in time if the process is simple enough for you to get it provisioned quickly, right? And the just-in-time access basically grants privilege only when needed and for whatever duration that you need. And it expires automatically after use, which reduces the security exposure window where, if say you have a standing permission with you all the time, that's a possible use case for an attacker once they get access to your credentials or whatever elevation that they might get. So some of the things that we are trying to deal with, like the approaches, right? Ephemeral credentials or time-based privilege escalation, elevation, or break-glass procedures, as well as some of the benefits being that you're reducing the attack surface for malicious actors. So one of the things that I want to talk about next is a policy-based approach, incorporating some of these based on your persona, based on the risk factor of a certain asset, and things like those, right? Now, when we say policy-based access, it's not just about moving beyond the traditional role-based access control, but rather it's about saying that you have a lot of contextual parameters that come into play. And based on those contextual things, you want to make your decision to do or grant access as needed, right? Now, in this example, or like some of the contextual factors that we've identified, say user attributes. When we say user attributes, maybe someone is authorized, when I say like a security level clearance, that's a user attribute that could be a factor in your decision. Or say something like resource sensitivity, an asset is high risk or medium risk, and based on that, you make a decision that you want to give them access or not. And also environmental factors. Are they accessing it from home? Are they accessing it from a company location? That could be a factor. And also a behavioral pattern. Is this something that they're accessing outside their typical work windows, or is it within their regular work hours? So many factors like these could be your policies, which can go and decide whether the user should get a necessary access. Now, the dynamic policy evaluation is another aspect of this, right? Like when you're with your static role-based access control, you get the access, but there's no periodic evaluation. Whereas with policies, you could have that, say if any of these contextual factors change, you could grant or revoke access based on that changing environment conditions. So this is like a meme from a 2015 e-commerce commercial where they say that, a certain understanding of things is not always the case. Like especially with zero trust, typically there's a belief that do we not trust anyone? But that's not the case, right? That's not how it works. When we say zero trust, it's about continuously verifying things rather than not trusting at all. So just wanted to put it out there. Okay, so we spoke about all these concepts, but then wanted to present like a hypothetical application and see how we could layer these different concepts that we spoke about and see how it can help reduce the risk score. So we went with, I just summarized what we are talking here. So we went with a hypothetical SaaS application called Cloud Finance, and we are saying that it has multiple tenants, which means that different companies could be using that product, and we want to have a clear boundary and demarcation of the accesses. And with this current example that we have, you'll notice that it has various of the OWASP vulnerabilities highlighted there, right? Like there is insecure direct object references, there is JIT tokens without proper validation in the generate token function, and then in the third, the create service account, you'll notice that there's orphaned service accounts, and if the employee leaves, it's going to be left lingering out there. And there is no standard offboarding process for these human identities. So with all these vulnerabilities in place, we wanted to give this the highest risk score, probably a 10 out of 10. And then we want to introduce each of the concepts that we just highlighted and see how it will help reduce the risk. So the first layer, we are trying to tackle the IDOR, in the insecure direct object reference aspect and see what we could do, right? We introduce fine-grained roles, and we also have like some resource-specific permissions. And then we authorize to make sure that the one who's accessing this data is either the owner of that data or they have the necessary permissions that will let them access the content. So this is just an illustration. So, but you can look at how simple measures can help mitigate some of the risks. And then the next we are introduced. So this again is not full of the Cloud Finance is still not out of trouble. It still has other vulnerabilities that we haven't addressed, which is the JWT JIT token exploits and orphan service accounts. So if we move to the next one, here we have taken measures to address how we can, like the service account related risks, right? And first we are introducing like a set owner where we are trying to assign some sort of an ownership, and we are also introducing a periodic access review or more like an access certification process, and we are also adding a way for them to transfer ownership. Like if say that service account, the employee who created the service account is terminated or is leaving the company, we have some offboarding process which will decide, based on the criticality of the service account, we might either do a transfer of ownership process, or we could do like deactivate immediately. Basically, it's a low risk and there isn't real big impact. So again, this helps reduce the risk score by 2 points in our example, but it still doesn't address all the vulnerabilities that are out there. So this is another illustration to show that typically when people join the company and they're granted, like we have the admin teams, which gives you certain level of permissions or roles, and we say that users do the things that are actually needed and do it right. But then over time, if you're with the company for more than 4 to 5 years, you keep accumulating all these different permissions and roles, and eventually you don't really need all of those, but you believe that you need them, and if somebody actually revokes your access, you worry too much, right? And when an actual instance of where you actually do the job, you end up figuring out like which one actually applies to me. So that's a comical way to show it. So moving on, So now we are introducing the third, or addressing the third aspect, which is perpetual access, right? And OWASP itself has one of the recommendations that the stateless JIT token should be short-lived. So in that theory, now we are going to generate some form of token with 4-hour validity out there as an expiration period, right? And then we are also going to issue like temporary API credentials instead of giving them like a perpetual access. So basically to say that it's a one-time use, or like whatever the duration that we want to grant, like maybe like an hour. After that, you should have a real justification as to why you need to do this again, right? So this also captures or audits the reason why you actually use this temporary API credential. So doing all of this, again, helps reduce our risk score by another 2 points, but then there is still vulnerabilities leading to like, say, why was this actually done, right? Like there's limited context in access decisions, and some of the policy-based access control comes into effect as the next step. So in this case, we are now adding some of the things that we were highlighting right now, like gather, from the user profile, determine certain attributes, or from the entitlement of the asset, determine certain attributes, or the environments. And based on, say, in this example, we have time of day based restriction, or whether they are accessing from the company location, and if the asset is high risk, then do we have to allow them? And there's also some of the other things, which is like rate limiting. Like, is someone trying to access the system too frequently? Maybe it's because their credentials got exposed, and then you have a malicious actor trying to DDoS, or things like those, right? So again, this policy-based access control does some form of continuous verification, and this helps us also mitigate some of the risks that come along with it. So we've spoken about these 3 different concepts and how through code we could address some of this. And right now we have like more sophisticated toolings rather than just code itself to address this, but just wanted to illustrate using code as an example. The last I wanted to touch upon with the advancement and evolution of AI in this space, we could also have like the user behavior profiling. When I say user behavior profiling, historically, how has the user acted based on the permission set that they've had, or like what things they typically do. And based on that, we could make certain decisions whether they need to be allowed to do the things that they are intending to do. And same applies to service accounts. Like, has a service account always access certain resources, or is it trying to access additional resources than what's typical of it? So overall, to summarize, right, like we've seen how like each of these solutions build on top of each other and help address each of those different OWASP vulnerabilities that are out there. And this AI-enhanced security added like more behavioral analysis or contextual awareness to prevent or bypass techniques. So each of these layers basically systematically address the different vulnerabilities or the attack vectors that are identified by OWASP. And for this next section, I think Dilip would be covering in detail about how AI enhances the access management stuff.
Thank you. We'll take a quick survey of different problems that exist in the identity governance space, and how different AI/ML techniques can be applied to those problems. Towards the end, we also have a question we can debate about, and then next we'll conclude after this session. One of the problems we tend to run into in identity governance implementations quite often is how do we categorize access into multiple buckets? How do we identify patterns between those access? Why is that important? Why is that problem important? Typically, in my company, there are 2,000 applications. Among each of those 2,000 applications, there is an average of 50 groups or entitlements. So that makes it more than 10K entitlements, right, across the company. Now imagine 50,000 employees getting access to 10K employees. the access management problem has exploded. So we need a way to reduce the number of access requests in the company. Otherwise, you would see tens and thousands of access requests every day. Administrators would simply be approving them or pretty much rubber stamping them at some point, which is why we need a way to combine access groups into larger buckets. We have a name for them. It's called role. In different companies, it's called in different ways. But role-based access control is one of the ways most of the companies typically implement to reduce the number of access requests in place. There are different machine learning algorithms that different companies can use to come up with these roles. K-means clustering, hierarchical clusters, and DB scan is one of the ways. K-means clustering is quite useful if you just want to identify, if your problem statement is, among these 200 groups, form 10 groups. If that's the problem statement you have, K-means clustering is a really good algorithm to use. Hierarchical clustering is really useful if your roles are hierarchical in nature, as in role composes sub-roles composes permissions, etc. Hierarchical clustering will be quite useful in that problem statement. DB scan is useful when your groups are not formed with the same density, as in there are some users with a large number of permissions and some users with a very small number of permissions. DB scan will be really useful in such scenarios. So this is one such problem. We'll walk through a couple of such more problems. There are more exist, but the idea is to give you a view of what tools can you use to solve different problems, and you can go and explore more about this. We also have the problem of anomaly detection in identity governance space, as in we want to detect when someone is accessing something out of their job role at some point. For example, if a user is accessing one of your critical resources from Syria or Iran or somewhere from Russia, you would want to block that. You would typically have some rule sets for it, but identity and access patterns go beyond typical rule sets. They are emerging, and a lot of patterns can evolve. It would be really hard for a rule-based system to catch up to those patterns. So these ML-based algorithms will help you detect those with a certain probability. Again, this is not a certainty, this is a probability. As long as you're good with that, these are good tools to employ. Z-score is one of those which will flag events when users with extreme values show up accessing your systems. There are other techniques like isolation forest and one-class support vector machines. Both these are quite useful machine learning techniques when it comes to anomaly detection. I would encourage you to check out more if you are solving some of these problems. Another good problem we have in the identity governance space is peer group analysis. What do I mean by that? You or your managers might be reviewing your access once every quarter. There might be an email they might be getting that's saying, hey, Dilip has all this access, do you want to approve it or not? And that's one problem. The second problem is you might be requesting access as a new employee, or whenever you get a new promotion, or whenever you're changing departments, you might be requesting access relevant to that department. Whoever is approving access, they would want to ideally know, just beyond the rationale you have put in there, do people with the same attributes as you in your own company have similar access or not? If you are accessing something way out of league, then that's something we want to flag and probably dig deeper into why do you really need that access. For example, if a typical software engineer in your company is not getting right access to cloud infrastructure, but you are requesting one such access, then that's something we want to look into, right? So that's an example of where peer group analysis would come into picture. There are a couple of algorithms here that would really help. Obviously, it is expected that you would have a data science team if you are solving these problems. So KNN, collaborative filtering, and graph embedding are some of these algorithms. You would want to kind of check out when ML is, machine learning is really experimental in nature. depending on the problem you have, you would want to try out multiple algorithms and validate the results and then pick an approach for you. There is no one-size-fits-all approach for everyone out there. Again, the problems I've walked you through are a sample set of problems. There are more. My goal was not to walk you through the laundry list of problems. Rather, my goal was to introduce you to the language and the tools available out there so that you can go and explore more. You might be thinking, having seen some of the problems I described, why can't I solve these problems with a simple rule-based algorithm? For example, if a user is accessing, like I said, if a user is accessing from Syria or Iran, I could just write a rule saying block the access request or block the access itself, right? It gets more complicated than that in large enterprise organizations. Rule-based access systems do solve some problems, and they solve it in a good way, and ML-based algorithms solve them in a different way. Especially when your problem space is exploding in terms of the attributes that come into picture, especially from one group to another, that's where the ML algorithms shine. Rule-based systems do not typically tend to scale because someone has to manually author those rules. By the time someone understands the problem, authored the rule, and then put that into the system, it would have already been a couple of sprints. And whoever need to, the malicious actor would have already infiltrated your system. So that's where you need an ML-based algorithm to come into picture to detect such scenarios with a certain probability. So I guess what I'm trying to say is you need to find a balance between rule-based systems and using algorithms depending on the problems you're trying to solve. And in almost all the large companies out there, you tend to see a healthy mix of hybrid approach where both rule-based approaches are used along with ML-based approaches to solve certain problems. In summary, we just saw what kind of different problems exist in identity governance systems, what kind of ML algorithms you can use, or what kind of toolbox exists out there to solve some of these problems. There are more problems for you to explore. You can use generative AI to generate entitlement descriptions in your company. For example, you might have run into situations where you might be requesting access to an AD group, and reading the AD group wouldn't make sense to you because it probably has a cryptic name. Generative AI can help you over there. It can help you generate descriptions so that your users can have a more easy access request pattern. And there are regression algorithms you can use for risk scoring access requests and making sure none of the risky accesses are getting approved. Such problems can be solved. I think in near future, you definitely see this kind of access request systems coming into picture. We are already seeing that in other areas of software getting evolved. Cybersecurity would also evolve to get here. I think we're almost on time here. I would like to see if there are any questions. If not, I think we can conclude here. Yeah. Yes.
Imagine a startup which has full security engineers.
Yes.
From what I'm seeing, this is good to have, but who's going to act on it? This is just knowledge. This is actionable intelligence, but who's taking action?
I think you bring up a really good problem. The teams that are building these solutions should definitely focus on actionability, and the teams who are configuring the alerts should also focus on making sure they are not creating rules or policies in such a way or deploying systems in such a way that the alerts are not over-configured. For example, if you get 100 alerts a day, it's pretty much a cry wolf situation, right? You would probably look at them for a couple of days, and then the third day you would tend to see, hey, this is the same alert, let me ignore them. So a healthy balance need to be found in between both. The people who are building these systems, they need to build algorithms in such a way that they're detecting riskier patterns with higher probability. And the people who are configuring these alerts, they need to make sure they're configuring alerts for the right reasons. And yeah.
They're happening for sure.
Yeah.
It's the number here. I'm not saying that they can be false positive. Assuming they've weeded out or rooted out all the false positives.
Got it.
How would we
I think you bring up a process problem, probably not a technical problem. Ownership needs to be delegated. Ownership of issues need to be delegated. Otherwise, you are dealing with a two-person security team who are dealing with issues from 100 different systems. It's not scalable.
so everyone gets to see alerts for it?
Exactly. Exactly. But authorization is already in place. It's trying to fix issues. Yeah. Yeah.
And
Got it.
and I think like the closed loop remediation is an example of it,
Yeah.
right? Like so yeah. Basically, the intent is, say you have somebody maliciously added in the target system, but then your IGA or any of these layers above that don't have that entry for that user, right? Now you could have change detection, which is going to say that, hey, you have somebody active in the target who's not supposed to be. Now, do you want your security team taking care of it, or delegate that to the asset owner to actually act on it? Yeah.
Joint response. It should be a joint responsibility. There should be a healthy mix of delegation and ownership between security teams. Thank you. Yeah. I think we're.
Yeah, I think we're good.
Okay, we'll take one last question then.
So, yeah, it's a great talk, by the way. I think you mentioned non-human entities, right? So, I guess you're talking about like faceless accounts or like services accounts. So, given that, can you tell me some best practices in terms of like how you want to offboard them? But the intention behind the question is, so in the later part of the section, you talked about like how you can apply like AA, ML strategies, right? So, do you generally like when you create like faceless accounts, what happens is they generally live long and you have like corresponding standard operating procedures to control and decommission them. But given that, can you give me some insights in terms of like how many faceless accounts you've probably dealt with and how AI and ML can retrain on how to decommission them?
Sounds good. Do you want to take that?
Yeah, I mean, mostly like service accounts throughout the organizations is never, standard size, right? Like we've had cases where like certain asset has about like 2,000 service accounts versus some things that has just 2. But those 2 have a significant impact versus probably all these 2,000 service accounts that are there in play. So the intent is with all AI and stuff, we want to first, or before even AI, like first as the IGA tool, we want to start standardizing to be aware that these are the possible service accounts that exist. And then you can start applying all these machine learning algorithms to say that what's the scope of access and what is the historical behavioral pattern to make the decision on are they accessing the right thing at the right time and things like those.
Oh, that makes sense because you're trying to control the blast radius. Thanks.
Thank you.
Thank you.